Our discussion on properties of triangles and we had discussed about what are the different types of triangles which are possible to be there. We also looked at some theorems which are related to the properties of triangles. Today what you're going to do is we're going to continue and look at a few more properties of triangles, and what I want to talk about is what is called the triangle inequality. Now, what does this triangle inequality really mean? Now, for that, I want to first draw a triangle and try to explain what it means. Now, let me just draw a triangle. So, let us take a triangle like that. And let me name them. So A, B, and C. Now let us also give lengths. Let us say that AC is probably A, AB is B, and BC is C. Now what a triangle inequality talks about is, let me just first define the rule, and then let me just define the rule, and then we'll actually discuss about the concept and probably do a few problems based on that. Okay. Now, what does the triangle inequality rule says? What it says is, now there are two rules here. One is called, I define that as, one is called a sum rule and the other is called the difference rule. Right. Now, what is a sum rule? Now, sum rule is as follows. It says that sum of two sides of a triangle will be greater than. Now, sum of two sides means sum of the lengths of two sides. So length is a word which I just omitted, but what I mean is length of the two sides. So sum of two sides of a triangle will be greater than the third side. Now, for example, here we can say that B plus C will be greater than A. Or I can say A plus C will be greater than B. Or I can say B plus C, sorry, already I have told that B plus A is greater than C. So I can tell, I can come out with all these conclusions if I do this. And what I want you to do is, I want you to draw a random triangle yourself. You know how to draw a random triangle, right? I just draw a line, then from the two ends of the line I can use the compass and draw an arc, and when the arc intersects I get a vertex. I can join the endpoints to that vertex and I get a triangle. It's a random triangle. Any random triangle you want to draw, and you can see that this rule will be correct. Now, I'm sure you're going to prove this later on, right? But right now I'm not doing the proof for this, but you will be able to prove that later on based on certain other laws that you're going to learn. Okay, so now what is the difference rule? So what is the difference rule? So we have seen the sum rule. Now the difference rule is actually stating that always the difference between two sides of a triangle will be less than the third side, right? So that is basically the other rule. So the difference between two sides will be less than the third side. And both these rules have to be valid for any triangles. Both the sum rule and difference rule will be valid. Now, if you look at the this particular triangle, what you can talk about? Let me just make this a little more cleaner. The third side, right? Now, difference between the two sides will be less than the third side. So what does this mean here? For example, I can say B minus C will be B minus C will be less than A, right? A minus, or not or, actually all this is and. In fact, it's not or. All this is and. Sorry for that. And this is also and, in fact. Similarly here, B minus C is less than A, and A minus C is less than B, and A minus B is less than C. So all this is going to be true if this ABC is a valid triangle, right? So for any triangle, both the sum rule, right, both the sum rule and the difference rule has to be obeyed, right? And so if you look at any triangle, now if three lines are given, the lengths of three lines are given, and if you're asked, can these lines form a triangle, you can easily apply the sum rule and difference rule and figure out whether it can really be a valid triangle. Okay, so okay, now this is basically the rule of triangle inequality. Probably let us just try out a few problems where we can use this triangle inequality and solve some of the problems. All right. So I hope you understood the two rules, the sum rule and the difference rule, and we are going to use these two rules to solve some problems. All right. So now let us look at this particular problem, right? So it is given length of three sides are given, right? And they are 2 centimeter, 3 centimeter, right, and 4 centimeter. Now, what is asked is whether this will form a triangle. Now, of course, if it has to form a triangle, it has to satisfy the sum rule, right? Now, let us look at the sum rule. Now, what you do is see this combination. 2 plus 3 is that greater than 4. So, that's great, right? 4 plus 3 is greater than 2. That's great. That's also satisfying, right? And 4 plus 2 is greater than 3. So, which means the sum rule is satisfied. So, sum rule is satisfied. Now, what about the difference rule? What about the difference rule? 3 minus 2 is less than 4, right? 3 minus 2 is less than 4. 4 minus 3 is less than 2. So that is also fine, right? And 3 minus 2, 4 minus 2 is less than 3. So which means the difference rule is satisfied. So since both the sum rule and difference rules are satisfied, this has to form a valid triangle. So this forms a triangle. So this is a very simple problem where given three lengths of the sides, we're checking whether it can form a triangle. Okay, just quickly save this T2. Save, replace. Okay. All right. So let's just get into the next problem. Now again, I'm given three sides, length of three sides. Right, and they are 7 centimeter, 8 centimeter, and 15 centimeter. Now, can this form a triangle? Okay. Okay. So length of three sides, 7 centimeter, 8 centimeter, and 15 centimeter. Can this form a triangle? Again, if I use a sum rule, so if I use a sum rule, 7 plus 8 is equal to 15. Right? 7 plus 8 is equal to 15. And so this basically is not okay. Not satisfying. Not satisfying sum rule. So this is not satisfying sum rule, right? And since it's not satisfying sum rule, it cannot form a triangle. Since the sum rule is not satisfied, it cannot form a triangle, right? So this is another a problem where you're seeing that the sum rule is not satisfied, and so hence it cannot form a triangle. Okay, so let's just save this, save, replace. Okay, now let us check another problem. Three, right? Two sides of a triangle are 5 centimeter and 9 centimeter long. Right? The question is, what can be length of its third side? Interesting question. Again, I have to see that it is satisfying both the sum and difference rule. Right? Now, what is the sum rule? Based on sum rule, if sum rule has to be satisfied, what should I say? I should say that 9 plus 5 is greater than, 9 plus 5 is greater than length of third side. Perfect, right? Now if difference rule has to be satisfied, 9 minus 5 should be less than length of third side, which means 4 centimeter should be less than length of third side, should be less than 14 centimeter. So what you're saying is the length of third side should be something between 4 centimeter and 14 centimeter, right? I just applied the two rules. So I have now two inequalities, 1 and 2. I just join together. So if I join 1 and 2 together, I get this. So the length should be greater than 4 centimeter but should be less than 14 centimeter. Pretty straightforward. I just apply the sum rule and difference rule, and I could actually conclude that the length of the third side should be between 4 centimeter and 14 centimeter. Excellent. All right. Okay. Now let us look at another problem. Let me just draw a triangle. Now I have A, B, C. And you know what is AM? AM is a median. I know some of you will be already knowing what a median is, but I would just still want to define what a median is. Excuse me. Median is a line segment connecting a vertex of a triangle to midpoint of its opposite side. That is what a median is. So here if you look at the median, it is connecting the vertex A with the midpoint of the opposite side, which is AB. Midpoint is M. So this is AM. And in fact, like that, I can draw three medians, right? So I can draw a median from this vertex, I can draw a median from this vertex, and I can also draw a median from this vertex, which joins the midpoint of the opposite side. And all these medians will intersect at one point. And that point is called the centroid of a triangle. You will actually learn that later, right? So don't worry about that. So AM is a median. Now the question that we have is, we have to prove, right? So prove AB plus BC plus AC is greater than 2AM. That's what you have to prove. Okay? AB plus BC plus AC is greater than 2AM. Now what I should do? I have to consider two triangles. I have two triangles here, right? If I consider triangle ABM, if I consider this triangle ABM, what I can say? I can say that AB plus BM is greater than AM. Do you agree? AB plus BM should be greater than AM, of course, right? Now, consider triangle AMC. That's this triangle, AMC. What can I say about that triangle? Again, I can say that AC plus CM is greater than AM. Okay. Now, I'm now going to do a small magic here. For that, I want to give an explanation, right? Now, can I say that 10 plus 2 is greater than 14? I can say that, right? Oh, sorry. 10 plus 2 is greater than not 14. 10 plus 2 is greater than 8. Right? Is that a right statement? 10 plus 2 is greater than 8. Now, I can also say 3 plus 4 is greater than 5. So I have two inequalities and both these inequalities are true. Now what I'm going to do is I'm going to add both add the terms on the left side of the greater than sign and add the terms on the right side of the greater than sign, and still you'll find the inequality is fine, right? So I can say 10 plus 2 plus 4 plus 3 is greater than 8 plus 5. I've just added up the terms. I've added up the terms. You can see that that is true. What is 10 plus 2? 12. 12 plus 7? 19. 19 is greater than 13, which is also true. So when you have an inequality like this, you can add the terms on the left side and add the terms on the right side, and still the inequality stands fine, right? So the same magic I'm going to do here, right? So I have 1 and I have 2. I have 2. Now from 1 and 2 I can say AB plus BM plus CM plus AC is greater than AM plus AM. Now what is BM plus CM? BM plus CM is nothing but BC. So I can say AB plus BC plus AC is greater than 2AM. So, which is a proof, right? So this is what a proof is, and the key part is, so here I can say from 1 and 2. So I've used both 1 and 2. I just added up the terms on the left side, added up the terms on the right side, and it holds good because you can see here this also holds good. So when you have two inequalities, I can add the terms on the left side and add the terms on the right side, and still the inequality holds good, right? So the same concept that I've used here is what I've used there, right? So the same concept which I've used here is what I have used here, right? So that's what it is, and hence the proof. Hence the proof that AB plus BC plus AC is greater than 2AM. Okay, fine. Let me just quickly save this. Probably should be T6. Okay, save. All right, so I think it's clear for you, right? So I had the AM median and I just used the sum rule, right? Because they are valid triangles, the sum rule should be satisfied, and hence I got two inequalities, and from there I actually got a proof. Okay, now let me just remove this. Let us look at the next one. Now here, next question in fact has a 5. Let me just draw this. So here we have a quadrilateral. Okay, let me just name this. It's A, B, C, D. All right, and I have to just join the diagonals. So these are two diagonals. Okay, now what I have to prove here is, AB plus BC plus CD plus AB plus BC plus CD plus AD is greater than AC plus BD. That is, the sum of sides, all the sides of the quadrilateral is greater than sum of its diagonals. That's what you have to prove. Yeah, from this diagram it looks to be very obvious, and that looks to be correct, but in maths you need proofs always, right? So Now, what you can do is, how can you arrive at this? So I can say that A AD plus AB is AD plus AB is greater than BD. And CD plus BC is greater than, yeah, so AD plus CD is greater than BD, AD plus AB is greater than BD, and I can also say, just a moment, a small mistake. AD plus AB is greater than BD, and I can also say CD plus BC is greater than BD, right? So here I have considered triangle ABD, and here I have considered triangle BCD. Okay, so if I consider these triangles, this is true. So which I can, in that case, I can say that AB plus CD plus BC plus AD is greater than 2BD. What I've done, I've summed up these terms, and as you have seen the last problem, still the inequality should hold good. Okay, now let us do another one. So this is the first thing which I've got, right? Now let us look at AC. Now let us look at triangle. So if you look at triangle ACD, I can say AD plus CD is greater than AC. That's if I consider triangle ACD, right? ACD. If I consider triangle ACD, that's true. And AB plus BC is also greater than AC if I consider triangle ABC. So if I sum up these two sides, or sum up the terms on the two sides, then I can say AB plus BC plus CD plus AD is greater than 2AC. So now you have two inequalities. Now from this, again, since you have two inequalities, this is one inequality and the other is the other inequality. From 1 and 2, what I can do, I can sum up again the left sides of 1 and right sides of left sides of 1 and 2 and right sides of 1 and 2, I can, and still the inequality should hold good, correct? So if I add up these two, I get 2AB, because they are same terms, AB plus CD plus BC plus AD, AB plus BC plus CD plus AD, both are same terms. So I can say both are added, means it's 2 into one term, right? So A2 into AB plus BC plus CD plus AD is greater than 2AC plus 2BD. So this actually I have got by considering 1 and 2 together. So when I consider 1 and 2 together, I just add up the terms on the left side, add up the terms on the right side. Still inequality holds good, as we've seen before. Just look at the last problem. I have actually given the reasoning for that. So, which means it is 2 into AB plus BC plus CD plus AD is greater than 2 into AC plus BD. Now I have 2 on both sides. So it's like this, right? Consider 2 into 10 is greater than 2 into 4. I can just cut 2 and still 10 is greater than 4. Right? I can do that. So same thing I can use, just like a equality. Here also I can use the same rule, and I can just cut both the 2 on both sides, right? 2 on both sides, and so I can cut this 2 and cut this 2, and so ultimately I get AB plus BC plus CD plus AD is greater than AC plus BD, and that's what I wanted to prove, right? That's what I want to prove here. So what I've done is I have just used 4 triangles here, in fact, right? So ABD, triangle ABD, triangle BCD, triangle ACD, triangle ABC. 4 triangles I considered, and in all these 4 triangles I considered the sum rule, came out with the inequalities. From there I got 2 inequalities, and from those 2 inequalities I got a third inequality here. This is a third inequality, and that led to the proof, right? So we have to build up one by one. It's a little involving problem. Please go through it. If you don't understand, just send a mail to me and I'm ready to explain to you. Alright? Okay, thank you. So let us go to the next problem. T7. Save. Okay. Now, the next problem. Okay, now let us get into the next interesting theorem, which is the Pythagoras Theorem. Pythagoras Theorem. So what is Pythagoras Theorem? I mean, the Pythagoras Theorem is related to right angle triangles, right? Now let me first draw a right angle triangle. Oops. Let me draw a right angle triangle. And here, this is a right angle, 90 degree, right? And I'll try A, B, C. Now, typically, BC is called the base. So this is a base, right? And this is called the altitude. And this is called the hypotenuse. Hypotenuse. So hypotenuse is in fact the side opposite to the right angle. So which is the side opposite to the right angle. Right? So the side opposite to the right angle is nothing but the hypotenuse. Now, what does the Pythagoras theorem say? The Pythagoras theorem states that in a right angle triangle, the square of the hypotenuse will be equal to the sum of the squares of the other 2 sides. Right? So that's what the Pythagoras theorem says. Right? In any right angled triangle, square of the hypotenuse will be sum of the squares of other 2 sides. So that's basically what the Pythagoras theorem says. If in any right angle triangle, the square of the hypotenuse, which is a side opposite to the right angle, will be sum of the squares of the other 2 sides. So here what does it mean? This means that, so that is this in triangle ABC, AC squared is equal to BC squared plus AB squared. So that's what it means, right? So sum of the square of the hypotenuse is equal to sum of the square of the other two sides. So that's what it is. Now I want to tell you what is the Indian contribution to this thing. In fact, Bodhayana, right? Bodhayana, who was again a rishi, and in Bodhayana's sutra, right, he has written the same Pythagoras theorem, and that is related to construction of Vedic altars for temples, right? So while constructing the Vedic altars, how you need to construct it, when he is explaining that, he is actually talking about the same right angle triangle relationship which is in the Pythagoras theorem, and he did it hundreds of years back before Pythagoras did, right? So it is there in our scriptures. You can actually do an internet search, or if you have a library or something, you can actually go and check about Bodhayana's invention, and he has already talked about the same theorem in when he related to construction of Vedic altars, right? So and I think he did it probably somewhere in 600 BC. It was before Pythagoras, right? Before Pythagoras. So interesting interesting information which I want to tell you. Nobody talks about Bodhayana. Everybody talks only about Pythagoras, right? But understand that there are some people, our forefathers, who also spoke about the same thing. And Bodhayana and Pythagoras have not met each other, because Bodhayana, I think, didn't live when Pythagoras was born, right? So he used to live before Pythagoras. So another interesting information, just to let you know again what our forefathers have done, right? Okay, all right. So I hope you have understood Pythagoras theorem. So from this you have understood what is hypotenuse of a right angle triangle. It is the side opposite to the right angle, and we have also seen that the Pythagoras theorem says that square of the hypotenuse is equal to sum of the squares of the other two sides. That's it, right? Now you can definitely construct a right angle triangle yourself and validate it. Measure the length of the hypotenuse, measure the length of the altitude, measure the length of the base, and see and find squares of each of them. What is square? AC square is nothing but AC into AC. AC into AC is what is AC squared, right? Similarly, BC into BC is BC squared, and AB into AB is AB squared, right? So you have to just find that. That's it. Okay, so let me just quickly save this. T7, I suppose. Save. Oops, cancel. So it should be T8 probably. Save. Okay. We just clear this and let us get into. So I think you have understood the Pythagoras theorem. Right now we are going to actually try to use that to solve some problems. Okay. Now there are a few other things which you can talk about, right? So given the Pythagoras theorem, so let me just draw a triangle again, a right angle triangle. A, B, C. So given a right angle triangle, there are a few things you can say, right? First thing is, longest side of a right angled triangle will be its hypotenuse. So the longest side will be hypotenuse. Now let us just try to prove that. So assume that it's C, B, and A and B, right? So based on Pythagoras theorem, what can I say? C squared is equal to A squared plus B squared. If C squared is equal to A squared plus B squared, in that case, what you can say is C is greater than A and C is also greater than B, right? So I can say that C is greater than A and C is also greater than B. That means C is greater than, C is the longest side, right? So AC is the longest side.